understand about radians is it is simply a way to measure an angle. Okay, so just like if I pull out this ruler, okay, you guys know that there are inches, and on the same exact ruler, there are centimeters. Okay, 2 different units to measure length. Okay, so a radian is just like a degree. It measures the angle of something. Okay. All right, so I'm going to start by giving you a definition of radian, which will help you understand how it is found. Okay, so the definition of a radian. Okay, it's a relationship between an arc length of a circle and its radius. Okay, so if you imagine a circle, what is the arc length around a circle? What am I talking about?
The circumference.
Okay, we're talking about the outside of the circle, which is also known as the circumference. Okay, so if we're talking about the circumference of a circle, what is the formula for circumference of a circle? What? To go all the way around a circle, it is what? Uh-oh, nobody knows the formula for circumference? Pi r squared is area. Pi d, but in terms of radius. 2, there we go, 2 pi r. Okay, so in terms of radius, it's 2 pi r. Okay, so that is 1 trip around a circle. Okay, so what we're going to do is we're going to kind of imagine that our r value is just going to be 1 to make this very simple. Okay, so our r length, the radius, is just 1. Okay, so this is called the unit circle. Okay, so why is it called the unit circle? Why would it use the word unit, the unit? One unit, that's why. Okay, the radius is simply going to be a unit of 1. Okay, I'm going to draw a perfect circle.
Yes.
Perfect. Okay, here's the center of the circle. Okay, and this length that goes straight to the left, like imagine the x-axis. Okay, so let's say our center is like at 0, 0 kind of. Imagine that. Okay, we're going straight to the left. So this is always going to be our terminal side. Okay, that's going to be 0 degrees, so that's like a flat line. Okay, so that's terminal. Terminal side. 0 degrees. Okay, so if I go straight up, what degree value would be straight up? What angle did I just draw? 90-degree angle. Okay, if I go straight out this way, what angle is straight to the left? 180 degrees. What? You did? Awesome. Okay, what angle is straight down? 270 degrees. What angle is all the way back to the beginning? 360. 360 degrees. Okay, so now what we're going to do is we are going to rewrite those angles in radians. Okay, so I said just a second ago that the circumference, or one trip around, or 360 degrees, is 2 pi r, right?
Right.
So if my r is 1, what is 360 the same as in radians?
1.
Okay, let's try again. Okay, so one trip around the circle, all the way around, 2 pi r. When my r is 1, so 2 pi times 1, what is 360 degrees the same as?
2 pi.
2 pi. The r is 1. 2 pi. There you go. 2 pi. One trip all the way around the circle is 2 pi's in radians. I'm going to cut that in half because that's easy. What's 80 degrees the same as in radians?
80?
180. This is 180.
Just pi.
Half of 2 pi is pi. Very good. Let's cut that in half and go to 90. What is 90 degrees the same as? Pi over 2. There you go. And let's even go further and cut that in half.
Oh.
Half a pi, right? Okay. What is, this is going to be 45 degrees because it's going to be exactly half of 90.
Pi over 4.
Pi over 4. Nice. Okay. So let's keep going the other way. So we got pi over 4, we got pi over 2. Let's go right here. Halfway in between 90 degrees and 180 degrees is 135 degrees. What's my radian? No, that's 90 degrees. It's going to be bigger than a half a pi.
1/3. No. 1. Oh, bigger than half? 3/4 pi.
Okay, we're looking at 135 degrees. Okay, so do you guys see what I just did on the top half? You see how I cut the top half in fourths? So this is technically 1/4. This is technically 2/4. What's 2/4 reduced to?
3/4. That's what I said.
So 3/4.
I can't speak right.
Okay. So I would say 3, to say that correctly, 3 pi over 4. So 180 degrees would be like technically 4/4. So if I go down from that, which
5/4.
is, yep, What degree though is that? 225? Okay, 5/4. Okay, so then what would 270 be? Oh, I wrote a 6. Oh my gosh, you guys. Jeez. Terrible. Sorry. Force. I don't even know where that came from. I know where it came from. So now we're at 6/4, and 6/4 reduces to 3/2, so 3/2 of pi. And the next one? Is 7 pi over 4. 7/4. Very good. Oh, yeah. Okay, so basically the idea of this radian thing is that they're going to ask you where certain angles lie, which within certain quadrants. Okay, so remember how I said the center is imagining it's like if you threw this circle and put it onto a coordinate plane with an x and a y axis, the center would just be right at the origin. Okay, so like here's my, no, I wanted a black. Black. Ah! No, 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 no. There we go. So here's my y-axis, and here's my x-axis. Okay, so if this is my x-axis and this is my y-axis, do you guys remember the coordinates? Which one is this quadrant? 1. Okay, so it goes 1, quadrant 1, using numerical numbers. 2, goes counterclockwise. 3, 4. No, that stops it. Okay, so what they're going to ask you to do is to specifically draw certain angles. Okay, can I move this up? Everybody done drawing that beautiful unit circle? Good? Okay. So if they ask us to draw 5 pi over 8, okay, we need to be able to draw that fairly accurately. Not perfectly accurately, but fairly accurately. Okay, so this is how I'm going to ask for you to draw this. I want you to start with drawing a circle on a coordinate plane. Okay, so I want you to go, here's my coordinate plane, and here's my circle. Okay, I know that this angle right here is pi. I know that this one right here is pi over 2. The one straight down is 3 pi over 2. And all the way around the circle is 2 pi. Okay, those are going to help you. Okay, now how do I draw 5 pi over 8? Okay, so basically what I need to do is I need to cut my pi into 5/8. My pi. Okay, so what part of the pi am I talking about? Okay, so the pi, since it's at 180 degrees, I'm only thinking about the top half of this circle. Okay, so what I have to do is cut it into 8s and then count out 5 of them. Okay, so I'm only looking at the top half. Okay, so I'm going to cut this into 8s. Ready? So it's already cut into half with the first line, right? This line right here cuts me into half.
Wait, what are we cutting?
Just the top half. Okay, if I put a line right here and here, now I'm in what? Fourths. Okay, so now to get to 8s, I'm going to cut each of those in half. 8, doot, doot, doot. Okay, so now I have 5/8 of a pi. Everybody good with that?
Maybe not 8.
Or I have 8/8. True. Yeah, you're right. Okay, so now how do I find my 5/8? You just count 5 of them. So I go 1, 2, 3, 4, 5. So my 5/8 is this one right here. Okay, so no, don't do that. Undo. So this angle from the terminal side to that blue line is 5 pi over 8. Not too bad? Shall I keep going? Okay. I think I should keep going. Let's do let's do 7 pi over 6. I think that would be good. Okay, 7 pi over 6. See if we can draw that. Okay, so start by drawing your coordinate grid with your circle. Make sure you have a perfect circle. No drawing ovals. Mine's perfect every time. Okay, so now what do we do? How am I going to start this? Take the top part and cut it into sixths. That's all I'm going to do. Take the top part and cut it into sixths. Okay, so here's half. There's 2. Okay, so now to cut it into 6, each of those halves need to be cut into thirds. Okay, so this is kind of an eyeball here. I have to cut this into thirds, so it's going to be boom, boom. Oh, that looks good. Boom, boom. Okay, so now I'm going to start counting 7. Ready? I'm going to come up here and do this.
But you're gonna run out.
Yeah, right? Okay, so you go 1, 2, 3, 4, 5, 6. So what do I need to keep doing? Now I have to go down into that third quadrant. Okay, so maybe I need to draw more than just the top half. Okay, it's possible that you go all the way over to the fourth quadrant. Okay, so this one is going to land right in that third quadrant. So from here to here, so you're drawing that blue angle, that's your answer. Okay, so that is 7 pi over 6. Okay, so do I need to do an example where you potentially can go all the way around the circle and then further than that? Yeah? Okay, so let's say we have, let me just make a really easy one, like 7 pi over 2. Okay, so if I have 7 pi over 2, what am I cutting my top half of my circle into? Into halves, right?
You just count.
Yeah, so this is like almost cutting, yeah. So this is gonna go, okay, ready? I'll count it up here. Okay, so you got 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves. Okay, so how do you draw that? Good question. Okay, so how do I know that I drew the angle 7 halves? Whoops. Sorry, let me redraw that. Dang it! Okay, 7 halves instead of just the 3 halves. Okay, so how I can tell is when I draw this little thingy down here, I'm going to go around and around again.
That's exactly what I did.
So that's how you know you went around a full circle and then further. That's like, this is how I got there. It's my little like trail. Okay, so it is also possible, yes?
Is this the same unit circle you can use to solve sines and cosines?
Yep. And we will do that. So it is possible also that you go in a negative direction. Okay, so if I asked you to find negative pi over 4, what would you do? You would just go downwards. Do I need to do that example, or do you understand it? Really fast? Okay, really fast. So draw negative pi over 4. Okay, so again, if we're going in a negative direction, what side should I start cutting? So this time we're going to go, instead of going up is positive, down is negative. Okay, so I'm going to start cutting this bottom half into fourths. Okay, so this would be, yeah, so that's halves and that's a fourth right there. Okay, so it's just the very first one, 1 pi over 4. So my angle, dang it, Wow. Oh, I lost my back button. It won't let me go back. There we go. So this is my angle. And you have to say that you went down to get to negative pi over 4. Okay, does that work? Everybody get that?
Yes.
You don't?
No, I didn't.
Oh, you do? Okay. Okay, so that's drawing angles.
And there's more.
There's more. There's a lot of stuff jammed into this, but it's very simple. It's not super complicated. What?
If I do another 3.
Another drink? Can you? I won't be that much longer. We've done the hard part. Okay, so they're going to ask you to find a coterminal angle. Okay, so a coterminal angle, the best example that I can give to you is like this question right here where I was drawing 7 pi over 6. So a coterminal angle would be 7 pi over 2 and 3 pi over 2. So if 7 pi over 2 and 3 pi over 2 are coterminal, what is a coterminal angle?
They're the same thing.
They're the same. They're one full revolution further. Okay, so I'm going to say same angle. Is it okay if I draw that? But 360 degrees or 2 pi, so one full revolution further. Okay, or potentially 2 full revolutions. You could go around twice, or 10 revolutions. No. Like, okay, so like, so let's do like a hard one, let's say. So let's say they say find the coterminal angle for 5 pi over 2. Okay, so you could draw this and figure it out. The fast way to do it would just be to add a full revolution. So how much is a full revolution? 2 pi. So if we add 2 pi to this, so if we have 5 halves plus 2 pi, which since we're adding fractions, we need a common denominator. What's the common denominator? 2. So then I would rewrite 2 pi as 4 pi over 2, multiply by 2, right? Oh, my bad. Oh, sorry. Okay, then you just add your tops together. 9 pi over 2. Okay, so 5 pi over 2 and 9 pi over 2 are coterminal angles. Okay, so you could also subtract 2 pi and go the other way. Okay, you can add or subtract 2 pi as long as it's a full revolution. Do I need to do that example, or are we good? Kind of get there. You'll probably get asked it on the homework. Okay. Converting between radians and degrees. I'm just going to say converting. So we got, let's go from degrees to radians. Okay, so if you're going from degrees to radians, all you have to do is multiply by its equivalent ratio, which is pi over 180. Okay, so because pi is equal to 180, or you could technically say 2 pi is equal to 360, that would be the same, but this is more reduced. Doesn't matter. Okay, so if you have 100 degrees and you want to convert it to radians, okay, you're going to multiply by pi over 180. Okay, and this is a little bit tricky in the fact that you are multiplying fractions together with a pi. I don't want you to multiply that directly in the calculator. I want you to give me an answer that is in terms of pi. All radians should be in terms of pi. Usually, not all of them, most of the time, if you can. Okay, so basically what I'm going to do is I'm going to take 100 and divide it by 180 and reduce that as a fraction. Okay, so this becomes 100 over 180 with the pi kind of sticking out. We're going to ignore that for a second. So what is 100 over 180 reduced to? 5 what? 5 ninths. So 5 ninths, and I just keep the pi upstairs. So technically 5 pi over 9. Do I need to do one more of those? That's pretty easy. That's just fractions. Okay, so if we go the other way, and we go from radians to degrees, anybody know what we do to undo it? Multiply by the reciprocal. Exactly. Multiply by 180 over pi. So, example, if you have 3 pi over 5, all you do is multiply by 180 over pi. So what happens in this scenario?
Pi goes away.
Pi goes away immediately. Boom, adios. Pi over a pi. 1 pi on top, 1 pi on the bottom.
So you have 3 pi.
3 times pi, not 3 pi's. No, 3 pi's is pi times pi times pi. That would be pi cubed. Okay, so what's 180 times 3 divided by 5?
108.
108 nights. 108. Is that it?
Nope.
I'm going to say yes, it's mostly it. I'm going to give you 3 formulas that you're going to write down. I'm not going to do an example, but I want you to write these down because they're plug and chug stuff. Formulas. Okay, so arc length. So arc length is equal to the radius times its angle. But the angle must be in radians for this to work.
Okay, wait, what is that? You say that?
Arc length is equal to the radius times the angle. And just so you guys know, arc length they'll refer to with an S.
To the radius times.
I don't know why they use an S.
Times the angle,
Radius times the angle.
but the angle has to be in radians.
Yep.
Alright, that's beautiful.
Linear speed. They're going to throw in this idea of linear speed. Like, linear speed is, the best way I can think of it is like a bicycle spinning and how fast something on the edge of it is moving.
And they refer to linear speed
As the arc length divided by time.
like what variable?
Oh, a variable? There is no variable for linear speed that I'm aware of. Okay, and they'll also ask you to figure out how fast an angle can speed. Angle can speed, angle can travel. And that's the angle divided by time. That also must be in radians. And last but not least, the area of a sector. Anybody remember what a sector is? A section of a circle. So like a piece of pizza. A slice of pizza. That's the way I think of it. A sector is a piece of pizza.
Could we have the sector, please?
Yeah, you can ask for a slice of sector of pizza.
I'm gonna come in.
Is that square?
1/2 pi r squared. Squared. 2. That's a 2. Alright, that should get you there. It is a lot. Just because it's new. It's brand new. What's that? Yep.
Where did you go to high school?
Helena High.
Oh, I knew that.